Okay, naming ionic compounds is actually very easy. There's a very few rules, and here's the rules for naming ionic compounds. First of all, remember that ionic compounds are metals and nonmetals, which will be important later next week. There are two rules. One is you name the first element. Regular name. The first element, the way that it's written, is always the metal. Rule number two is that you give the second element an IDE ending. The second element is always the non-metal. That's how they're written. The note here, that's how you spell note, N-O-T-E. The note is that you get to ignore all the subscripts when you're naming, which will make sense in a second. So something like this. Every ionic compound is always ever two things. The metal, which is listed first, and the non-metal, which is listed second. When they're both off the periodic table like this, magnesium and oxygen, they're called binary ionic compounds. So one, binary because there's only two things here, one and then two. That's it. When you name them, you name the metal first, which is called magnesium. And what is the second element called? It's oxygen, but what are you going to call it? Oxide. Okay, it's that easy. Name the first one, second with the IDA ending, that's all. When it has subscripts, like, okay, that, you still do the exact same thing and you don't worry about the subscripts. So if it says if there are 2 calciums and 3 nitrogens, again, not super important for naming ionic compounds. All you worry about is naming the first, which is called what? Calcium. And then sometimes the IDE ending gets a little weird. This is an example where it's nitrogen. You drop off the entire last half and you call it nitride. Do you want to see a third one, or are you happy with that simplicity? Okay, good. So writing formulas gets a little more challenging. When you write the formula for an ionic compound, there's still a couple rules. And there's some exceptions too, which you probably will hate. The first rule is that I would, and at least right for now, is write the ions out. What are the ions again? What do they have? All the stable atoms have neutral charge, or the ions have some sort of charge, either positive or negative. And then, this will be vague, but it'll make sense in a second. You do this thing called crisscross. If you end up with Mr. Bauer next semester, he'll call it drop and swap. Some of you call it drop and swap, or crisscross. Or flip and dip. I just made that up. It's not called that. But anyway. So you crisscross, and I'll show you what that means in a second. And then the note here is that you don't write ones. So the example would be strontium fluoride. When you have that written out as words and you want to write the formula, the first thing I would do is look up the ions on your periodic table, which you wrote down the ion, the charges, okay? I'm only giving you metals from the first 2 columns, and I'm only giving you non-metals from the right side of the periodic table today. Things will get more challenging tomorrow. But right now, this is it. So look at the charge for strontium. What is it? is +2. It's in the +2 column. Very good. Now we're not looking for fluoride. That's not in the periodic table. What is on the periodic table? Fluorine. So work backwards and figure out what fluorine is. And fluorine's a -1 charge. Eventually you can do this part in your head, and you won't need to write all this out, but I would suggest for today it's probably a good idea to write it out. The crisscross is very simple. Take this 2. Well, no, back up. Hold on a second. Every compound is going to be electrically neutral. Okay? So if the charge on this is +2, and the charge on this fluorine is -1, how many of these am I going to need to cancel out one of these? How many fluorines do I need to cancel out one strontium? I need 2, right? Because we want them to be neutral or overall 0. And so I would need 2 of these to cancel out one of those. And that ends up being the formula. That's the math way. The easy way is to take this 2 and put it right there. And take that 1 and put it there. But don't write the ones. And don't move the charges. The charges go away. It's a little trick, a little mathematical trick. Some David Blaine stuff. Okay? So the formula becomes SRF2. That's it. I should tell you, this is the correct formula. Not having some weird random charges up here, you know, pluses and minuses and things that you left over. It's only letters and numbers that are a subscript. That's it. If you keep your 2 up here, I'm not going to give you credit. If you put a 1 here, I'm not going to give you credit. Okay, so it's only numbers and subscripts and letters. Another one. Barium phosphide. Take a second, why don't you try it? American capital side? Your worst nightmare. Yeah. So barium phosphide. Again, the charges for barium is what? +2. Phosphide, we're not looking for that. What are we looking for? Phosphorus, which is a -3, I believe. And again, if you want to think about the math here, you want this to be electrically neutral. Okay? So all the positives have to cancel out all the negatives. Is there a common multiple of 2 and 3 that would get you there? It's 6, right? And so we're doing the math here. To get this to be +6, I would need 3 of them. To get this to be -6, I would need 2 of them, and that ends up being your formula. Okay? That's the hard way. The easy way is just take this 2 and put it right there, and take that 3 and put it right there. And that's it. And the formula is Ba3P2, barium phosphide. Pretty fun, right? I should tell you there's one more thing that you should know, and that is when you have the same charge, as in calcium oxide. When you have the same charge, those charges go away. So calcium, if you look it up, is +2. Oxide is not oxide. What are we looking for? Oxygen, it's got what charge? -2 column, right? And these just cancel out. +2 cancels out -2. And we want to write the lowest whole number ratio, and that's a 1-to-1 ratio. So we write CaO. You don't write the 2 and the 2. So you might get stuck if you move this 2 there and you move that 2 there, and you write them both. That's technically not correct. You have to reduce them to the lowest ratio. And so in this case, all we do is just get rid of both those 2's, and you write 1 and 1, and we don't write the 1's anyway, so that's how it's all written out. And that is how you write formulas for ionic compounds.